Welcome everyone. I am Dr. Radharaman from Bangabasi Morning College discussing ozone hole. Today we will learn the ozone layer formation, its depletion, impacts of its depletion on human communities and agriculture. Let's begin with ozone layer. We know for last 450 million years the earth has had a natural sunscreen in the stratosphere called the ozone layer. This layer filters out harmful ultraviolet radiations from the sunlight and thus protects various life on the earth. Now, what is ozone? Ozone is a form of oxygen. The molecule of oxygen contains 2 atoms, whereas that of ozone contains 3. In the stratosphere, ozone is continuously being created by the absorption of short wavelength ultraviolet radiations. Ultraviolet radiations less than 242 nanometer decompose molecular oxygen into atomic oxygen by photolytic decomposition. Then the atomic oxygen rapidly reacts with molecular oxygen to form ozone. Ozone, thus formed, distributes itself in the stratosphere and absorbs harmful ultraviolet radiations of 200 to 320 nanometer wavelength and is continuously being converted back to molecular oxygen. Absorption of UV radiation results in heating of stratosphere. The net result of this reaction is an equilibrium concentration of ozone. Ozone concentration in about 24 km of the stratosphere, that is from 16 km to 40 km away from Earth's surface, is about 10 ppm. This equilibrium is disturbed by reactive atom of chlorine, bromine, etc., which destroy ozone molecule and result in thinning of ozone layer, generally called ozone hole. The amount of atmospheric ozone is measured by Dobson spectrometer and is expressed in Dobson unit DU. 1 DU is equivalent to a 0.01 mm thickness of pure ozone at the density it would possess if it were brought to ground level at 1 atmospheric pressure. Normally, over temperate latitude, its concentration is about 350 DU. Over tropics, it is 250 DU. Whereas at subpolar regions, except when ozone thinning occurs, it is on an average 450 DU. It is because of the stratospheric wind which transport ozone from tropical towards polar region. Now the thinning of ozone layer, that is the Antarctic ozone hole, was discovered by Dr. Joe C. Farman and his colleagues in the British Antarctic Survey, who had been recording ozone level over this region since 1957. During spring season of South Pole, September to November each year, ozone depletion is observed. Steep decline has been observed since mid-70s with a record low concentration of 90 DU in early October of 1993. Chlorofluorocarbon CFC are mainly responsible for ozone depletion in the stratosphere. CFC are a group of synthetic chemicals first discovered by Thomas Migle Jr. in 1930. CFC11 and CFC12 are the CFC most commonly used as coolant in refrigerator, in air conditioner, as propellants, cleaning solvents, sterilant, and in styrofoam. CFC release in the troposphere reach the stratosphere and remain there for 65 to 110 years, destroying ozone molecules. In 1974, Rowland and Molina warned that CFC are lowering the concentration of ozone in the stratosphere and predicted severe consequences. Scientists discovered that at the Antarctic region the temperature during winter drops to -90 degrees Celsius. Water droplets in clouds when enters these area forms ice crystals. CFC get collected on the surface of these ice crystals and destroy ozone much faster. The depletion is 10 to 25% and it is less than that observed at South Pole. Nitrous oxide emitted by supersonic aircrafts during combustion of fossil fuel and use of nitrogen fertilizers breaks ozone molecules. Chlorine liberated from chlorofluorocarbon also break ozone molecules. The chemical reaction started in Antarctic region of spring continues till nitrogen dioxide is liberated from nitric acid formed in the stratosphere by photolysis, that is breakdown by sunlight. This nitrogen dioxide combines with chlorine and stops further destruction of ozone. Let's see what effects of ozone layer can cause on human. Ozone layer depletion in stratosphere result more UV radiation reaching the earth, especially UVB of 290 to 320 nanometer wavelength. The UVB radiation affects DNA and the photosynthetic chemicals. Now any change in DNA can result in mutation and cancer. Cases of skin cancer which do not cause death but cause disfigurement will increase. Easy absorption of UV rays by lens and cornea of eye will increase in incidence of cataract. Melanin producing cells of the epidermis will be destroyed by UV rays resulting in immunosuppression. Fair people that cannot produce enough melanin will be at a greater risk of UV exposure. Phytoplanktons are sensitive to UV exposure. Ozone depletion will result in decrease in their population, thereby affecting the population of zooplankton, fish, marine animals. In fact, the whole aquatic food chain will be disturbed. Yield of vital crops like corn, rice, soybean, cotton, bean, pea, sorghum and wheat will decrease. That's all for today. Here are the references from which I have taken the information and pictures. Meet you in the next topic. Thank you.